Prepare yourselves for an extraordinary cosmic event of unprecedented scale. Betelgeuse, the red giant star situated at the galaxy's edge, is emitting ominous signals across the universe. Utilizing the James Webb Space Telescope, astronomers have made a profoundly unsettling discovery about this massive celestial body. Renowned astrophysicist Brian Cox has issued a grave warning, leading to the looming question: are we about to witness a catastrophic supernova explosion that could permanently alter the night sky? Let's delve into this phenomenon in the vast tapestry of the cosmos, where stars are born, live out their lives, and eventually die in spectacular displays. One star has recently captured the attention and concern of astronomers and the public alike. This star is Betelgeuse, a red supergiant of immense size and age, prominently located in the constellation Orion. Its distinct reddish hue and variable brightness have long fascinated observers, but recent developments have intensified interest in this celestial giant. As we explore Betelgeuse's nature, we find ourselves on the brink of a potentially monumental event in its life cycle. But what do these changes in Betelgeuse indicate? Could we be witnessing the prelude to a cosmic spectacle of unimaginable magnitude? Betelgeuse, approximately 764 times larger than our Sun, is a stellar giant. Its colossal size is almost beyond human comprehension. Imagine a star so vast that if it were to replace our Sun, its surface would extend beyond Mars' orbit, engulfing Mercury, Venus, Earth, and Mars. This immense size is not just a testament to Betelgeuse's physical attributes, but also signifies its stage in the stellar life cycle. As a red supergiant, Betelgeuse is in the twilight of its existence, a phase characterized by expansion and cooling after a life spent fusing hydrogen into helium in its core. But how old is Betelgeuse? This star, believed to be around 8 to 8.5 million years old, is relatively young in human terms, but ancient in the context of stellar lifetimes. Its current red supergiant phase is the culmination of millions of years of stellar evolution, marked by dramatic changes and processes that have transformed it from a hot blue star to the red giant we see today. The life cycle of stars like Betelgeuse is a tale of transformation driven by the relentless forces of nuclear fusion and gravity. Betelgeuse's distinctive reddish hue is another hallmark of its current stage. The red color results from its relatively cooler surface temperature compared to stars like our Sun. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's cooler surface registers temperatures around 3,500 Kelvin, allowing it to emit light at wavelengths that give it a red appearance. But this color is not just a visual trait, it provides insights into the star's physical condition and the processes occurring within its vast gaseous expanse. Adding to Betelgeuse's mystique is its historical color change. Ancient Roman and Chinese records suggest that around 2,000 years ago, Betelgeuse appeared yellow. It was only in the 9th century that Arabic scholars first described it as red. This color shift over human history is not just a detail in the annals of astronomy, but also a clue to the star's evolutionary path. The variable brightness of Betelgeuse is another intriguing aspect. It is a semi-regular variable star, meaning its light periodically waxes and wanes, a characteristic dance of luminosity that has fascinated astronomers and sky watchers for centuries. Typically, Betelgeuse undergoes a 400-day cycle, along with a longer cycle that stretches about 5 years. These cycles have been documented as far back as 1836 by Sir John Herschel, and possibly even earlier in Aboriginal oral traditions. What makes Betelgeuse truly enigmatic is not just its changing brightness, but also its irregularity. Unlike many stars that follow a predictable pattern, Betelgeuse occasionally deviates from its rhythmic dimming and brightening, hinting at complex and less understood processes occurring within its colossal form. In a recent groundbreaking revelation, Betelgeuse captured the attention of astronomers and stargazers worldwide with an unexpected and dramatic change in its appearance, now famously known as the Great Dimming. In late 2019, Betelgeuse, the red supergiant and one of the brightest stars in the night sky located prominently in the Orion constellation, began to dim mysteriously. This dimming was so notable that it started losing its brightness at an average rate of 0.01 magnitudes per day, reaching its lowest point in February 2020. Betelgeuse, typically visible to the naked eye even in areas with light pollution, became noticeably fainter, a change that amateur observers could easily spot. However, monitoring Betelgeuse activities poses a challenge due to the time paradox. When we observe a star like Betelgeuse, we are seeing it not as it exists in the present, but as it was in the past, because of the time it takes for light to travel to us. In the case of Betelgeuse, which is approximately 725 light-years away, the light we see today left the star nearly 7 centuries ago. This time lag makes predicting and monitoring sudden changes in a star's behavior difficult, as we are essentially looking into its past. The dimming event of Betelgeuse highlighted the inherent difficulties in real-time astronomical observations and the limitations of our understanding when dealing with vast cosmic scales and the time paradox they introduce. This celestial drama of Betelgeuse was closely observed by Andrea Dupree, Associate Director of the Center for Astrophysics at Harvard and Smithsonian, and her team. They used the Hubble Space Telescope to study the giant star as part of a 3-year study on variations in its outer atmosphere. These observations provided a unique insight into the dynamics of a variable star like Betelgeuse, which expands and contracts, causing fluctuations in brightness. By analyzing Hubble spectra, the researchers measured the movement of material in Betelgeuse's outer atmosphere, particularly focusing on magnesium-2 lines which indicate the star's atmospheric conditions. These observations revealed material moving at speeds of about 200,000 miles per hour from the star's surface into its outer atmosphere. This hot, dense material eventually extended millions of miles from Betelgeuse and was the precursor to the dust cloud that led to the star's dimming. Dupree and her team estimated that about twice the normal amount of material from Betelgeuse's southern hemisphere was lost over the 3 months of the outburst. This mass loss was significant, especially considering that Betelgeuse, like all stars, continuously loses mass, albeit at a rate far greater than that of our Sun. The scale of this mass ejection and the subsequent dimming sparked discussions among astronomers about whether this event could be a precursor to a supernova explosion. Betelgeuse's proximity, about 725 light-years from Earth, adds to the intrigue, as any such explosion would be visible from Earth and provide a rare opportunity to observe a supernova up close. However, the question remains, what does this dimming event mean for Betelgeuse's future? Is it a sign of an impending supernova, or simply a unique episode in the star's long and complex life? Several theories were proposed to explain this sudden change. One prevalent theory suggested a phase in the supernova explosion process gaining traction due to the common belief that Betelgeuse is nearing the end of its life. Another popular theory implicated dust, possibly from the star itself, obscuring our view. Betelgeuse, like other red supergiants, is known to shed material, and this material could form a dense enough dust cloud to dim the star's light from our perspective. A third explanation considered changes in the star's photosphere, the visible surface layer, which could affect its apparent brightness. In-depth analysis using various observational methods helped unravel this mystery. Spectroscopic studies indicated a drop in Betelgeuse's effective temperature, suggesting that the dimming could be due to a large dark spot on the star's surface. This theory was supported by the observation that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming, indicating significant changes on its surface. Ultimately, the key to understanding this unusual phenomenon came from Hubble Space Telescope observations, revealing that Betelgeuse's dimming was most likely caused by a significant ejection of hot material into space. This material formed a dust cloud that obscured a portion of the star's surface, effectively reducing the amount of light reaching us from Betelgeuse. The dust cloud was thought to originate from superhot plasma, which erupted from a large convection cell on the star's surface and then moved through its hot atmosphere to the colder outer layers. As it cooled, it formed dust grains, creating a cloud that obscured light from approximately a quarter of the star's surface. Hubble's ultraviolet light spectroscopic observations starting in January 2019 were crucial in constructing the timeline leading up to Betelgeuse's darkening. These observations captured signs of dense heated material moving through the star's atmosphere in the months before the dimming. In December 2019, several ground-based telescopes also noted the star's diminishing brightness, particularly in its southern hemisphere. This material, initially brighter than the star's normal luminosity, eventually formed a dark cloud as it moved outward and cooled. The theory was that this outflowing material and resulting dark cloud caused the star's sudden dimming. The scale of this ejection was monumental, thrusting Betelgeuse into the astronomical spotlight. The star expelled an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This ejected material, believed to weigh several times as much as our Moon, was significant not only for Betelgeuse but also for our understanding of stellar mechanics. But what is a coronal mass ejection, and how does it relate to Betelgeuse's situation?